The asynchronous task queue system, hereafter referred to as ATX, is a distributed message passing framework designed for deferred task execution and durable work persistence. This documentation describes the internal architecture, configuration parameters, and operational behavior of ATX version 3.2.1. The system provides guaranteed delivery semantics through persistent storage backends and implements multiple retry strategies for failed task execution. All timing values are specified in milliseconds unless otherwise noted. Queue storage is abstracted through a pluggable backend interface. The default implementation uses a file-based append-only log with periodic compaction. Tasks are stored as JSON documents with mandatory fields: task ID, queue name, payload created at, and priority. Optional fields include retry count, max retries, scheduled for, and execution context. The queue name field determines which worker pool will process the task. Task ID are generated using UUID version 4 with timestamp-based ordering. The enqueuing process is transactional and idempotent when deduplication is enabled. Tasks submitted with duplicate external identifiers will not create redundant queue entries. The deduplication window defaults to 1 hour. The enqueue operation returns immediately after persistence confirmation, providing the caller with task ID, enqueue timestamp, and estimated processing time. The estimated processing time is calculated based on current queue depth and historical task duration metrics. Worker processes poll the queue at configurable intervals specified by the poll interval ms parameter, which defaults to 500 milliseconds. Workers acquire a batch of tasks up to the batch size limit, defaulting to 25 tasks. Each acquired task transitions to the processing state and receives an assigned worker identifier and a deadline timestamp. If a worker fails to update task status before the deadline, the task becomes eligible for requisition by other workers. Task execution is initiated by invoking the registered handler for the corresponding queue name. Handlers are stateless functions that receive the task payload and return a result object containing a status field and optional output data. The execution environment has a default timeout of 30 seconds, which may be overridden per task through the execution timeout ms field. Timeouts result in forced termination and automatic retry scheduling. Handler return values must conform to a standard result schema. Successful execution returns status equals success with optional output field. Retriable failures return status equals retry with an optional error message field. Non-retriable failures return status equals failed with required error details and failure classification fields. The failure classification field must be one of invalid input, external service error, resource exhaustion, or internal error. Retry logic follows an exponential backoff strategy. The initial retry delay defaults to 1 second. Each subsequent retry multiplies the delay by the backoff multiplier parameter, which defaults to 2. A maximum jitter of plus or minus 10% is applied to prevent thundering herd scenarios. The maximum number of retries is configurable per queue and defaults to 5. Tasks exhausting their retry budget transition to the dead letter state. Dead letter handling is configurable per queue. By default, tasks are stored in a persistent dead letter queue accessible for manual inspection and reprocessing. An optional alert on dead letter flag enables notifications when tasks enter the state. The dead letter retention days parameter controls how long failed tasks remain discoverable, defaulting to 30 days. Queries against dead letter queues support filtering by failure classification and timestamp ranges. Scheduled task execution is supported through the scheduled for field. Tasks with a scheduled for timestamp in the future remain in the scheduled state until that time arrives. The scheduler component processes scheduled tasks with 1-minute granularity. Scheduled tasks may be cancelled before their execution window by task ID. The scheduling subsystem maintains in-memory indexes by scheduled for timestamp and queue name for efficient lookup and batch transition. Priority-based processing is implemented through separate queue buckets for each priority level. Priority levels are integers from 0 to 99, with lower numbers indicating higher priority. Workers maintain a priority weight array to determine which queue bucket to poll at each iteration. The weight distribution defaults to inverse exponential, biasing heavily toward lower priority values. Priority starvation prevention is implemented through a fairness coefficient that increases polling frequency for higher priority values after extended idle periods. Metrics collection is implemented through a pluggable instrumentation interface. The default implementation exports metrics in Prometheus text format. Key metrics include tasks and queue total, tasks processing current, tasks completed total, tasks failed total, task processing duration seconds, and queue depth current. All metrics are labeled by queue name and handler name. Histogram buckets for processing duration default to 50 milliseconds, 500 milliseconds, 2 seconds, and 10 seconds. Configuration is loaded from a YAML file or environment variables. The configuration root contains sections for backend, workers, queues, and instrumentation. Backend configuration specifies the storage implementation and connection parameters. Worker configuration includes pool size, poll interval ms, and heartbeat interval ms. Each queue section overrides default values for that specific queue, including max retries, execution timeout ms, and priority range. Worker heartbeat is implemented through periodic status updates. Workers report their current task ID, processing start time, and estimated remaining time at intervals specified by heartbeat interval ms, defaulting to 2 seconds. The heartbeat process is non-blocking and operates on a separate background thread. If a worker fails to report for a duration exceeding heartbeat interval ms multiplied by failure threshold, defaulting to 5, the task is reassigned to another worker. The state transition diagram defines valid status transitions. Tasks begin in the pending state. From pending, they transition to scheduled or processing. From scheduled, they transition to processing at the scheduled for time. From processing, tasks may transition to success, retry, failed, or timeout. All terminal states are success, failed, and dead letter. Timeout transitions follow the retry logic path if retries remain available. Cluster coordination is handled through a distributed lock implementation. Leader election for scheduler and cleanup tasks uses a configurable backend such as etctor-readies. The lock acquisition timeout defaults to 5 seconds. Lock lease duration defaults to 30 seconds and is renewed continuously by the holding process. If renewal fails, the process gracefully surrenders the lock and waits for the next election cycle. Operational maintenance involves periodic compaction of the append-only log at archival of completed tasks. Compaction is triggered when the log size exceeds the compaction threshold bytes parameter, defaulting to 1 GB. Archive tasks are moved to cold storage specified by the archive backend configuration. Log segments are retained according to the retention policy setting, with a default retention period of 90 days. This concludes the ATX technical specification document.